Manari here, back to the Game Engine project. This part has been already programmed and compiled, and it's a resource manager for the project. Currently it is only working on most of the pre-made assets that we were using, but for fonts and text we are using precompiled asset instead of the raw data. Text files and textures are saved as is. Sprites include an additional info of their data. There is a very easy way of how the game later loads everything. So let's go into the code. The main difference that you would see is in the load function. You see that we use the resource bank resolver and we get the elements, and you would also see that we do the same for the font textures and the font atlas. With this setup I can have a precompiled asset pack that does a certain work, and I can update it and modify it later without requiring a name change on each individual component. Additionally, it also saves me time on the creation of the glyph atlas and the creation of the glyph texture. There have been some changes to the shader. It is now something almost universal that takes 5 integers, 2 for the position, 2 for the size, and 1 for the sprite. I might even add a 6th element and change those to short, because don't think that I would ever need anything more than a short to denote position. Same for size. And if I have another element, I would be limited to, how much is it? 2 to the power of 16 sprites, 24, it is 1k times 32 or 64. Yeah, that's enough sprites, I think. This is the relative location of the screen in a 0 to 1 ratio. 0, 0 is the top left, 1, 1 is the bottom right. It is similar to the locations of the OpenGL, but instead of -1 to +1, it is 0 to 1 only. Rendering still takes place the same. And here we see that we just used that shader, set isText to 1 or isText to 0, and we can see that it renders and have some nice colors and have very clean environment. So this is the resource manager. Let's go back to what it actually does. The resource manager is consisting of a file that contains a bunch of resource buffers. A resource buffer is consisting of a header, which holds the data, basically what type, what size, and some additional info on that specific type. And then it has a free buffer of data. It uses the C allocation schema of allocating a header plus size of data for a data type to make that data type an extension of its original size. It copies the info and the data into the place, then return the buffer. Make resource from file basically takes the file with the parameters and the type and make a resource from that. For instance, when we make an ASCII font texture, we're using the same way that we open the font and iterate over all of the extended ASCII table to query for all the glyphs available, know what is the size that we're going to use for each surface. After we do that, we create a surface glyph for every single glyph that is provided, and then we free that surface. Those surfaces are after we know the sizes, we make a surface that can fit those glyphs in addition to their size. Basically, this is always either bigger or equal to the amount of glyphs available. And the destination width and height is based on the minimum pack size, which means how small can the glyph actually be. And then when we blit the surface, then we blit it from x equals 0, y equals 0 to the size. So that RGB surface creates the surface that we can blit onto, and with every glyph that is provided, we blit that glyph onto that parent surface. Then when we do, we make a resource out of that surface using the glyph's pixel, the size, which is the bytes per pixel, the height and the width, multiplication of all of those, because we have height times width pixels, bytes per bit, bytes per pixel, meaning that the size is the multiplication of all of those. We just copy the size amount from the pixels stream, and we also copy the info, which is a text sprite info. So the size of here is 20 bytes, and just copy 20 bytes from minfo, and that is making the buffer. Then it frees the glyph surface so that we don't have any memory leakage. We return the buffer. Same goes for any other thing. They just use the make resource after they have all of the required data to make it. String for file, basically open a string file, convert everything to a string. If it couldn't load successfully, it outputs that it could load successfully. Otherwise, it just makes a resource as a text file with the actual string size, which also include the null terminator and a pointer to the string. It doesn't have any info size or an info buffer because it's just a text. Make sprite from file, make texture from file. All of those are basically the same. Load image, know how many rows and columns and height, pixel format, width, all of that to just make a resource. This is the same thing that we have seen in the ASCII atlas, is also very similar to us making the ASCII atlas, but instead it is going to basically allocate this data structure that contains the height, width, and size. The height and width are the minimum pack size, and the size is the amount of glyphs. And after that, it has a data, which is just an array of glyph data. Glyph data is just a character, is the character drawn, and the advance. This is a very simplified way of making it, because those are the only things that are needed for the glyph atlas to work. I don't need to know if the glyph atlas has a reason not to draw it because it's an empty glyph or because it's a glyph that has no drawing area. Those are two different things. One of them has an advance, the other one has an advance of 0 because it doesn't exist. An example of a non-drawn glyph is the spacebar. It has an advance of some number that is set by the font, but it has no size to the glyph itself, meaning that it is not drawn. Yeah, if minimum x is different to maximum x, then it is drawn, meaning that it has some width to it. And that is the resource manager. It also overrides fopen because I am really annoyed at the fact that I need to use fopen-s for Windows, and I can't use that for Linux because for some reason there is not fopen-s, because it uses a different type of stuff. And of course there is the CLI, command line interface. What we see here is the instant compilation when we take extra arguments. If arg1 is something, there's that. And it just goes through the things. It has a main menu, can load an existing project, make a new project, and let you edit the project if you selected the project properly. When you make a new project, ask you for the project path, the output, header, and enum name. The outputs and the header paths are relative to the provided project path. It doesn't really print the relative path correctly. It prints the path that you inputted as the project path through the through the string input. This base path is later added to the output and the header path so that you can get your project files in the correct folder. Enum name is the name of the enum that you're going to use for here. As you see, asset shader underscore e, and then it has the 3 elements. And then there is the shader armas, which is containing all of those shaders just in a singular file. One thing that is very easy with those approaches is that I can take this unified shader and I can then copy paste this folder, rename it, and have completely different shaders, but they would still the same shader name, but has a completely different vertex shader that instead only takes a sprite, and the location is set by the screen offset and location that is derived from vertex ID. Because we know that in our chunks there are 256 vertices, this creates a location vector with a tile size. From that screen offset, we offset each tile individually to the correct position. This is not the most efficient way to do that, but this is good enough because we're still using only 2D, and beyond that we are also using a geometry shader anyway. So we are already going to have vertices creating more vertices. There is the compile command, all of the other things. This compile command also outputs all of the error messages that you can find. The only thing that it doesn't compile for is things like shaders that are compiled on the game itself. This thing is using the resource bank, is holding the path, the name, the type, and the parameters for every resource buffer that is going to be created in the resource itself. This resource buffer is usually holding null. In compilation it doesn't hold the null, but before compilation ends, here it's just showing that. And basically you try to compile the bank element. If you fail, you do cleanup and you return false. Then you try to write the header enum. If you fail, you do a cleanup, then return false. And then you try to write the resource file. If you fail, you do cleanup and return false. Otherwise, you do cleanup and return true. There are better ways to do this, but I really don't care. Also, you can add and remove the resources as you see fit. Elements are held within a vector, so that removing the elements is not that much of a chore. The removed resource is removed by the index. That is all about the resource manager. And this was the resource manager. With this, the engine is currently in alpha. I can show the resource manager itself. If we load this, we see all of the shaders. This allows us to edit the properties. Universal one vert is the vertex shader. Basically everything else the same. So this is the resource manager. That is the alpha version of the engine. And with this alpha version, we can go and start making the game. A full disclosure, the actual game itself is already halfway through the first stages, because I was doing stuff and I couldn't actually record my programming. Sorry about that. And with that, goodbye.